Hi everyone, today I'm going to talk about the homework 5 sample questions. So let's take a look. The first question. A dry cleaning establishment claims that a new spot remover will remove more than 70% of the spots to which it is applied. To check this claim, the spot remover will be used on 12 spots chosen at random. If fewer than 11 of the spots are removed, we shall not reject the non-hypothesis that p equals to 0.7. Otherwise, we conclude that p greater than 0.7. So from this question, we can know first the non-hypothesis is p equals to 0.7, and the alternative hypothesis is p greater than 0.7. So from this we can know if fewer than 11 of the spots are removed, we shall not reject the non-hypothesis. So which means if x less than 11, then not reject h0. Otherwise, then x greater or equals to 11, then we reject h0. Then let's take a look at the question. For the problem A, evaluate alpha assuming that p equals to 0.7. So let's see. You can know alpha is the probability that reject h0 while h0 is true. So this equals to reject h0, that's x greater than 11, while p equals to, the h0 is true, so p equals to 0.7. So it's a binomial distribution, so we can just use the binomial CDF function. So it's x equals to 11, then 12, and binomial x 12 trial, and the probability is 0.7. Then how we get this value? We will use the exile to get this. So in exile, there is a function called binomial distribution range. So at this place, you can type in the trial numbers. It's 12 in this case, and the probability is 0.7. Then these two numbers, the S and the S2, is the range, where the range starts and where the range ends. So it's 11, then 12 is 0.085. So we get the answer, 0.085. So for the B, beta equals to probability fail to reject h0, while the alternative is p equals to 0.9, so p equals to 0.9. This equals to probability x less than 11, while p equals to 0.9. So it's 11, 0. You have to conclude the 0 in this CDF, so you need to be careful here. So it's binomial x 12.9. So we use the same formula here, binomial distribution range. So it's 12.9, 0 to 10. So we get the answer is 0.341. Okay, that's the first question. Then let's take a look at the second question. An electrical firm manufactures light bulbs that have a lifetime that is approximately normally distributed with a mean 800 hours and a standard deviation of 40 hours. Test the hypothesis that mu equals to 800 and against the alternative mu doesn't equal to 800. If a random sample of 30 bulbs has an alternate average life of 788 hours, use a p-value. So let's take a look at this question. The null hypothesis is mu equals to 800, right? Then the alternative hypothesis is mu doesn't equal to 800. And we have the sigma equals to 40 and the sample size equals to 30. So in that case, we can write down that's the first step. Second step, we write down z0 equals to x bar minus mu divided by sigma divided by square root n. That is 788 minus 800 divided by 40 over square root 30. So the result for that is minus 1.43. Then third, we compute the p-value in this problem. P-value equals to, because the null hypothesis is doesn't equals to, so if z0 less than minus z alpha over 2 or z0 greater than z alpha over 2, then we reject. So there's two parts of the critical region. So this part and this part. And so the p-value is 2 times pz less than z0, because it's a negative value here. So equals to 2 times 0.0505. You can find this number in the normal distribution table. It equals to 101. So in the problem, we don't have a significant level, so we do not have to conclude the problem. So let's take a look at the third problem. Past experience indicates that the time required for high school seniors to complete a standardized test is a normal random variable with a mean of 35 minutes. If a random sample of 20 high school seniors took an average of 33.1 minutes to complete this test with a standard deviation of 4.3. Test the hypothesis at the 0.05 level of significance. That mu equals to 35 minutes against the alternative that mu less than 35. So we follow the four steps. The first is H0 is null hypothesis is mu equals to 35, and the alternative hypothesis is mu less than 35. So we reject the H0 if the T0 is less than T alpha n minus 1. Because it's less, so it's not alpha over 2 here, it's just alpha. So second, we get the T0. T0 is x bar minus mu divided by s over square root n. So it's 33.1 minus 35 divided by 4.3 over square root 20. So we get the result is minus 1.976. So third, step 3. we have to here we first use the critical region method. So critical region method is just this one. So the t alpha n-1 is t.05, then 19. This equals to minus 1.729. So we can make a conclusion that since t0 less than t alpha n-1, so we reject h0. So mu is less than 35. So here we will also use the p-value method. So we have this, so we have this minus 1.976. So we can get the p-value here is t less than t0. So this equals to, if you look at the table, this equals to 0.0312. And this value, we make a conclusion here. Since this is p-value, since p-value is less than alpha, so we reject h0. So mu less than 35. So that's sample questions today. Thank you for watching.